Hello students, welcome to AcadShala.
Let's roll on with 3R series, that is recall, revise, retrieve. Today we are going to start with Part 7, Chapter 13, Magnetic Effects of Electric Current.
But before starting today's session, it would be great if you like this video, share this video and subscribe to our channel AcadShala. This gives us a lot of motivation to keep creating these kind of videos for you all.
The first question says, what is a solenoid? Draw the pattern of magnetic field lines of, first part, a current carrying solenoid, second part, a bar magnet. Now students, before doing this question, something should come in your mind, the concept which we have studied. You should visualize the diagrams and then go for the question to answer it. Now children, when the word solenoid comes in your mind, so if you close your eyes, you will see the diagram with lot of closed turns. That is, there will be so many closed turns are there that is wrapped very closely. Yes, that means the closed turns are very close to each other, wrapped very closely. That is, one cylinder coil is prepared. That is, from which insulated copper wire. And that is only known as solenoid. Whenever the word solenoid comes, it should come in your mind, it should be visualized in your mind that there are many turns which are very close to each other and they are wrapped very closely to each other. That is copper insulated wire. And these turns are wrapped closely to form a cylinder which is known as solenoid. Now children, the field pattern in solenoid is what? Field pattern in solenoid is like a bar magnet. Are you seeing on the screen children? Yes or no? So this is solenoid and this is bar magnet. Now, in solenoid what happens? Magnetic field lines, you are seeing it, are parallel like this. See, they are parallel or not? They are parallel. And one more thing, very important. They are equidistant also. So this point is very important, children. What did I say? Magnetic lines are parallel and equidistant. This is the main point, children. That is, the field is uniform. So, concentrate on the keyword to understand the solenoid. That is, magnetic field lines are parallel and equidistant, and that is why it is uniform. And you should also know that the magnetic lines, children, from where are they emerging? You are seeing the north and the south pole in both the diagrams, yes or no? Yes, you are watching over here. So, the magnetic lines will emerge or immerse. That means from where? That means from the north pole. And where it will go? It will terminate at the south pole. Over here also, starting from north pole, emerging and then terminating towards the south pole. So in both the diagrams, which is of solenoid as well as magnet, that is bar magnet, we have two poles, north and south pole, and the magnet lines are emerging from north pole and terminating towards south pole. Have you understood, children? So the definition says, a solenoid is defined as a coil consisting of a large number of circular turns of what? Of insulated copper wire. These turns are wrapped closely to form a cylinder. So this is the definition of a solenoid, which I told you in detail. So put it in words and your answer is in your quote, as well as the marks which will turn are also in your quote. Right, children? Okay, the second part says, draw the pattern of magnetic field lines of a current carrying solenoid. Yes, this is a current carrying solenoid which I've shown you. So these diagrams are very, very important. So it can be asked, or you should be able to draw the diagram in a very well versed manner. And a bar magnet is also here and the solenoid is also here. So please do not forget to practice these diagrams, which is very, very essential for your exams. Right, children? So let us go to the second question now. List two distinguishing features between the two fields. Okay, so this is really very important question which you need to know it very well versed manner. Okay. Now, children, whenever we do any question, first we should, again, I'm saying it, you should know the concept before and then implementing that concept in the question, whatever is the demand in the question, accordingly. Now, children, I know it that in solenoid, magnetic field lines are parallel. Yes, and equidistant also. That also know it. I know it very well about it. Yes, children. So these are the main points which I told you beforehand. Now, children, for doing this distinguishing features, it is also very important question. Now, in bar magnet, that is outside the bar magnet, you are seeing it over here. Magnetic field is there, right? Yes, but in solenoid, it is not significant. That means we are seeing lot of magnetic lines in the bar magnet, but in solenoid, it is not significant, or we can say it is negligible. Right, children? Now, if I say if you want to change the, say, magnetic field of solenoid, you can change. But how? That means if the current is more, what will happen? More will be the magnetic field. If the current is less, so what will happen? It will be having less magnetic field. So always remember this concept which has to be utilized. Okay, another thing. Now, if I want to increase the magnetic field, what else I can do in solenoid? Anybody can tell me? Yes, I can add what, children? I can add soft iron core inside the solenoid. Absolutely correct, children. Hence, magnetic field will increase. And I can do one more thing. What is left? Okay, number of coils. That is, if the number of coils which are very closely packed, what I should do? Number of coils, if it is increased, magnetic field also increases. Okay, so I've come to know so many things, children. With the help of it, I can increase the magnetic field. Now, I also know, according to my knowledge, that solenoid is an electromagnet, whereas bar magnet is a permanent. I cannot change anything in bar magnet. So that is why it is a permanent magnet. So after knowing all these concepts which I've discussed with you right now, now we have come to the conclusion to give an answer for this question which says, list two distinguishing features between the two fields. So the first point says, magnetic field outside the solenoid, yes, is negligible as compared to the bar magnet. Absolutely correct. So immediately I can put up the first point. Second says, magnetic field of solenoid can be varied as per our requirement. That means we can change as per our requirement, which I told you, just by changing current or core of solenoid. But in bar magnet, it is fixed. Hey, I can do any change in the solenoid, but not in bar magnet. Why? Bar magnet is permanent magnet, but in the solenoid, I can change accordingly. Next point says the bar magnet is a permanent magnet, which I told you right now, whereas a solenoid is an electromagnet. Okay, that is, it acts as a magnet only when, children, when an electric current is passed through. Then only it will show a change. But surely it will show a change. Okay, children. Okay, last, the strength of the magnetic field of a bar magnet is fixed. Yes, I know this. That is unaltered. Whereas the strength of the magnetic field of a solenoid depends on what, children? Depends on the electric current that is passed through it. Strength of magnetic field of a solenoid can also be increased. How, children? By putting a soft iron core inside a solenoid. So, if I was aware about the concept, I was able to put up in words, in lines, to grab the marks in the exam, and that too full and fledged. Not even half mark can be deducted if I know the concept of the content very, very well. I can put up in my answers very well to take the marks. So, with this, children, I wind up the session. Keep on revising these concepts, these questions on and on till you understand. And please do revise on the daily basis. And your exams are very nearby. So, that is why I'm telling you, keep on revising, keep on watching AcadShala, and you will rise and you will shine like a star. God bless. I wind up the session. Bye bye, children. God bless.